Hello viewers, I am Kausalya. Today we are going to solve problems related to superposition theorem. The problem is find the current in the 150 ohm load resistor and the power consumed in it by the principle of superposition. So here this is our circuit diagram and this is our 150 ohm load. And here we are having two voltage sources. One is 240 volt and another one is 140 volt. So we are asked to calculate the current in this resistor and again the power consumed by this resistor, right? So here the first thing is we are considering our 240 volt source. So whenever we are considering a source, you see here the sources are given with internal resistance, right? So these internal resistance should be also taken into account. So first we are considering our 240 voltage source. So here we have to remove this 140 voltage source. Though we remove this 140 voltage source, we have to consider this 0.5 ohm resistance, right? So when you redraw this circuit, you see only 240 voltage source is considered and the rest everything remains the same, and this internal resistance of this 140 voltage source is also considered here, that is 0.5 ohms. Then as usual here we are reducing that is we are going to find the total current that flows through the circuit. To find the total current we have to find the total resistance. So here in this case you see these three resistors are connected in series, right? So the total resistance is just you have to add these three values. So we are getting 152.5 ohms. Then the next thing is you see here these two resistors are in parallel. So now we are going to calculate the total resistance of this parallel combination, which is nothing but R1 into R2 divided by R1 plus R2. So that gives the answer as 25.06 ohms, right? So now when you look at this circuit, again these two resistors are in series, not two resistors. Here we have to consider this 2 ohm also. So these three resistors are in series and the voltage is 240 volt. So here the value of current is given as I is equal to V by R. The value of V is 240, right? Divided by the resistance is summation of these three values. So when you add these three values, finally the value of current is 6.8454 amps, right? But what we need actually, we actually need the current that flows through this 150 ohm resistor. So again just you gradually move back, right? Consider this circuit. So here the total current is 6.8454, right? So this current gets divided between these two resistors, right? So by current division rule, we can calculate the current that flows through this 30 ohm as well as through this 152.5 ohm. So how come this 152.5? It is nothing but it is a combination of 2 ohm and 150 ohm and 0.5 ohm, right? So the current flowing through this 152.5 ohm is nothing but it is the current that flows through this path, right? Can you understand? So you see the current flowing through this 152.5 ohm is nothing but it is the current that flows through this 2 ohm, through this 150 ohm and through this 0.5 ohm, right? Therefore, so current through this 150 ohm resistor is given by, you see, total current into opposite resistance. So what is the resistance which is opposite to this? It is 30 ohm. So 30 divided by 30 plus 152.5, right? So that gives the answer as 1.125 amps. Am I making the concept clear here? That is the current flowing through this 152.5 ohm is same as the current that flows through this 150 ohm, because this 152.5 ohm is nothing but it is a combination of these three resistors, right? That is why we are calculating the current that flows through this 152.5, right? And we are saying that the current flowing through this resistor is same as the current flowing through these three resistors. So here we are concluding current flowing through this 152.5 ohm is same and this is equal to current flowing through this 150 ohm resistor, right? Okay, considering 140 volt source alone, now we are going to consider this 140 volt source. So here this 240 volt source is removed, whereas its internal resistance is considered, okay, whose value is 2 ohms. So since we are considering source, our source is on this side, right? So here we are solving the resistors from this side, from the other end. So here this 2 ohm and 8 ohm are in series, right? So that becomes 10 ohm. So when you solve this 10 ohm becomes in parallel connection with this 30 ohms, right? So the total resistance will be 10 into 30 divided by 10 plus 30. So that gives the answer of 7.5 ohms, right? So here I had not drawn each and every step of this circuit. You see, when you combine these two, that becomes 10. That 10 comes in parallel with this 30, right? So when you combine this 30 and 10, that gives the answer as 7.5. So this entire circuit has 150 ohm, 2 ohm and this 7.5. Wait, let me draw. So here this 2 ohm as usual, here 150 ohm, and here we are having our 7.5 ohm, and here I am having this voltage source along with this 0.5 ohm. Right, this is our simplified circuit. Can you guess? These two are in series, you see, because current flows in this way, because here we are having the source. So current flow by this way, and here it gets divided into 2. And here the same current flows through this 8 ohm as well as through this 2 ohm. So 8 plus 2 gives 10, right? So here you see at this node current divides between these two. So these two resistors are in parallel combination. Therefore 10 into 30 divided by 10 plus 30, that gives 7.5. So I had simplified this circuit like this, right? So again when you look at this, you see this 150 ohm, 2 ohm, this 7.5 and this 0.5, everything are in series here, right? So here I am first initially combining these three resistors, 2, 150 and 0.5. So that gives 152.5. Again when you redraw the circuit, you see these three resistors are here combined as 152.5, and this 7.5 here and this 140 volt is drawn here, right? So now we are going to find the current. So current is I is given by V by R. So here the voltage source is 140 volt and the total resistance is this. So that gives the answer as 0.875 amps. Right. Now we are going to calculate the current that flows through this 150 ohm resistor. So here when you look at this diagram, it is quite simple, because okay, the current source, that is the total current that starts, okay, that flows from this 140 volt flows through this 150 ohm. Therefore the current flowing through this 150 ohm is nothing but our total current, that is 0.875 amps, right? Now we are going to calculate the net current that flows through this 150 ohm resistor. So to calculate a net current, we have to consider the current constituted by these two current sources, right? So here you see the current that is given by this 140 voltage source is nothing but 0.875, and it flows in this way, okay, from bottom to top. Again when you consider this circuit, you see here the current flows from top to bottom, right? So here the current direction is from top to bottom, and here the current direction is from bottom to top. So the current directions are opposite to each other. Therefore the net current flowing through this resistor, we have to subtract those two things, okay? So when you subtract, the answer is 0.25 amps. Therefore the total current that flows through this 150 ohm resistor is 0.25 amps, right? We are proceeding with our next problem. The problem is using superposition theorem, obtain the current in EA in figure below. So here this is the given circuit diagram. We need to calculate the current that flows through this branch EA. right? So again, this circuit has two voltage sources. We have to consider only one voltage source at a time, right? So here the thing is considering only one voltage source. So we have to remove this two voltage source. So when you draw, you see here our circuit diagram will be like this, right? Here we are going to use matrix method to solve this problem, right? We can use any method, but since we are having a bridge circuit, it will be more convenient if you go with matrix method, right? So we have to assume the current directions by our own. It is always up to you, okay? Here you see, since we are having a voltage source, we are assuming the current direction from minus to plus, right? So this is the direction of current that flows through this path. And here this I1 and I2 I had taken by myself. It's up to you. You can take in either clockwise or anti-clockwise. Whatever may be the directions you take, the final answer will hold the same, right? So here you see, this is I1, this is I2, and since it has voltage source, I had taken I3 like this. If you like to take I3 in opposite, then you have to write the value of this 1 volt as minus 1 volt, right? That's it. Now we are going to frame matrices. So V is equal to I into R. So here this network has 3 loops, right? So the current flowing in loop 1 is I1, loop 2 is I2, and loop 3 is I3. So here you see, when you look at this first loop, there is no voltage source. There is no voltage source in second loop also. So here it is 0, 0, and finally in third loop we are having a voltage source of 1 volt. So here it is 1, right? And the next thing, current flowing through these loops. So in the first loop it is I1, second loop it is I2, and in third loop it is I3. So just write it. And here the next thing is, we have to write the resistance matrix. So I believe you people will remember this type of sum we had already solved. So in the diagonal elements are nothing but sum of elements present in that loop. So when you look at this loop 1, you see it is 2 plus 8 plus 6. So which is nothing but 16. Again when you look at the second loop, it is 4 plus 8 plus 5. So that gives 17. So I had written here. And for the third loop, you see it consists of 6, 5 and 10. So which is nothing but 21. So these diagonal elements are nothing but sum of the resistors present in their respective loops, right? Then the next thing is, look at loop 1 and 2, or else you can simply write, you see, 1, 2, 3 and 1, 2, 3. Here this element is common for loop 1 and loop 2. So here this is loop 1 and this is loop 2. So which element is common? Here this 8 ohm is common, and again you see the direction of current flow. Here when you consider loop 1 it is like this, and when you consider loop 2 it is also in the same way. Therefore you can simply write 8. Okay, since the direction of current flowing through this 8 ohm resistor is same for I1 and I2, here I am writing it as 8. If the direction is in opposite, then you have to write minus 8, right? So here it is 8, and the next thing is 1 and 3. So this is your loop 1 and this is your loop 3. So what is the element which is commonly present? It is our 6 ohm, right? Again look at the direction of current. So here I1 flows like this, right? I1 flows in this way, and when you look at I3 it flows in opposite way, right? Therefore here we are writing the value of resistance as minus 6, right? So once you write this first row, you can fill this first column, right? Then the next thing is 2 and 3, because we have already filled these two values. So element which is common between 2 and 3. So this is your 2 and this is your 3. So here what is the resistor which is common? It is 5 ohms, right? Again look at the direction. So here current flows like this and current flows in this way. Again when you consider loop 3 also the current flows in the same way. So here it is simply 5 ohms, right? Now what is the thing? We should calculate the current that flows through this path. So what is the current that flows through this branch EA? It is nothing but our I3. So we need to calculate I3. So before calculating I3, we should calculate the value of del. So here del is nothing but determinant of the resistance matrix. So here you have to take this determinant. I hope you people know because this belongs to basic mathematics. Anyway, I'll explain the things, right? So first consider, that is, here you should consider these signs, plus, minus and plus. So when you consider 16, it is plus. Okay, so 16 into 7, you have to, okay, you have to eliminate this row and this column. As you are considering 16, that respective column and row should be eliminated. So 17 into 21 minus 5 into 5. So 17 into 21 minus 5 into 5, right? And the next thing is minus 8. So minus 8, again you have to remove this column as well as this row. So here the thing is 8 into 21 minus of minus 6 into 5, right? And finally it is minus 6. Okay, here we have to consider plus, but there is a minus here already. So plus into minus will give you minus. So minus 6, you have to remove this column and this row. So 8 into 5 minus of minus 6 into 17. So when you finally solve, here the answer is 2876, right? Since we need I3, we need to calculate del 3. So how to write del 3? You see, you have to replace the third column with respect to voltage source. So here you see, since we need I3, right? So we have to replace this column with the respect to voltage source with this element. So here we have replaced this third column, right? And the value of del 3 is 208. And the value of I3, it is nothing but del 3 by del. So just substitute the values here, and finally the current is 72.3 milliamps, right? So one part of the problem is over. Now we are going to consider our 2 voltage source here. So when you consider 2 voltage source, our diagram is in this way, right? We have removed our 1 voltage source here. So this is our circuit. Again, we are considering the current in the same directions, right? So as usual, we have to frame the matrix. So V equal to I into R, right? So voltage is, when you look at this first loop, here the current, you see, it flows from minus to plus, right? Sorry, it flows from plus to minus. So it is minus 2. Again, when you look at this second loop, look at this direction, again the current flows from plus to minus, therefore it is again minus 2. And in third loop, there is no voltage source, so it is 0. And here I1, I2, I3 are the respective currents that flows in the loop. And the next one is resistance, right? So when you look at the loop 1, what is the summation of resistance? 8 plus 2, 10, 10 plus 6, 16. So again, this doesn't make any difference provided if you consider the direction of current in the same way as you have taken in the first step, right? So that's the reason, don't change the direction of current, let it be as such. Once you have decided the direction of current, follow the same thing till the end, right? So the value of del is calculated already, okay? No need to do it again and again, the same value. And the next thing is del 3. So to find del 3, you have to replace this third column with this element. So when you replace this, the value of del 3 is, it is minus 28. So I3, when you calculate, it is del 3 by del, therefore it is minus 9.736 milliamps, right? Now we need to calculate the current that flows through the branch EA, right? So when you consider 1 voltage source, the current flowing through EA is 72.3 milliamps, right? In the same way, when you consider 2 voltage source, the current flowing through EA is minus 9.736 milliamps. Therefore, current through the branch EA is, you see, one is with positive sign, another one is with negative sign. So here just simply subtract, right? Therefore, the current that finally flows through the branch EA is 62.564 milliamps, right? Here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.